Hi, everyone. Good to be with you here today, and welcome to how continuous testing can help make the right trade-offs between protection and customer experience. All right, just a few housekeeping items here before we begin. First off, the webinar is being recorded so that you can reference back to the presentation at a later time. Make sure to send us all of your questions if we do not get to cover them here during the presentation, and the links to the recording will be made available after the presentation. For today's webinar, we have Guy Ariely, the QA CTO of Digital AI. We have Mike Woodard, the product owner of Digital AI App Protection, and myself, Juan Lugo. I am the Digital AI Continuous Testing Product Marketing Manager. Okay, so before we discuss how continuous testing can help make the right trade-offs between protection and customer experience, let's briefly go over the Digital AI approach, which entails leveraging the 5 essential offerings in order to create a truly intelligent platform that connects not only all the software development and delivery efforts to business outcomes. The platform connects agile planning, as you see here, software delivery, application security, and quality so that you can meet all the increasing demand in the market. Ultimately, the goal here is to continue to provide the business context throughout the entire value stream of delivery. Okay, so as you can imagine by now, the demand for faster product releases, optimal app performance, and ultimately happy customers are the top priorities for companies looking to differentiate themselves in this rapidly changing and highly competitive market that we are in. With that, we have the IT leaders striving to adopt modern testing approaches such as continuous testing and automated testing that can help companies not only keep pace with the modern delivery, but also ensure that they are providing an optimal digital experience that drives the value for business and customers. And ultimately, what it boils down to is that testing early, better, and faster is the new imperative for organizations. So as continuous delivery and integration accelerates release velocity, manual testing quickly becomes the bottleneck that creates inefficiencies in the value stream, since it's slow, it's expensive, and it's resource intensive as well. Another common issue is when testing occurs at the end of the software lifecycle. This is typically where developers receive test results, and it's also when defects and significantly more time-consuming to fix, and as well as the delay that can take to reach the time-to-market goal. It can drive up the cost and increase the business risk of software release candidates. And so we have companies increasingly taking a different approach where testing starts earlier and it happens continuously throughout the delivery process using automated approaches. This testing strategy enables faster feedback. It entails the loops to be shortened as well. And so developers and testers can fix defects when they are easiest, fastest, and cheapest to fix. So again, the main takeaway here is that most companies are still missing their deadlines as their demand increases. And this is because they are still manually testing the code, which requires testing windows, and therefore creating bottlenecks of tests that need to be executed, while this never coincides with the ability of the time of the QA teams have, resulting in an endless backlog of testing performance. Okay, so here we have 3 common challenges experienced by enterprises utilizing disjointed quality and app protection offerings. And throughout the presentation, we'll discuss the benefits of deploying these offerings from a single platform. The first main takeaway here is the importance of gaining full visibility into all potential paths of execution within an application, which enables organizations to optimize their software delivery, the overall team efficiency, and the customer experience while utilizing the product. So this allows enterprises to leverage full visibility into issues that can potentially reduce the software delivery efficiency and hinder the customer experience. And we have QA and testing teams which are faced with the challenge of balancing the process execution while optimizing their app protection measures. This means that organizations must figure out a way to adapt quickly to meet both the demands of the organization, but also improve the old processes as well. This ultimately comes down to an organization's ability to optimizing their app security while ensuring that they are increasingly scaling their testing performance. And finally, we'll cover the importance of understanding how app protection impacts the customer experience and the overall app performance. And you all can imagine now that the app protection can cause performance segregation But when you deploy an interoperable solution that syncs all of the critical components, you're able to visualize these potential issues earlier and address them before they impact the customer experience. Okay, so in relation to visibility, what is the significance here? It's the ability to mitigate the risk into all paths of execution, as well as the preventable app latency that is experienced and the performance degradation that we just discussed. So we have three main factors that testing platforms should provide the visibility into. Those are transactions, logs, and metrics. Transactions like the duration that it takes to perform a login or a logout sequence. Some critical metrics are things like that organizations need to provide visibility into that directly tie into performance, and these things include the CPU utilization to any given time, the maximum level of CPU utilization, as well as memory and battery utilization, the network privilege, and the speed index. And specifically with the speed index, this is an advanced concept that tells you exactly how much it takes for your application to load the elements onto the screen. In the example demonstrated here on the right, in this one in particular, it took this 1 second for the application to load the elements to the screen, which is one of the factors to consider from a performance degradation perspective. Okay, so now let's get a bit more specific on the challenges and benefits of the organizations face with app security optimization from a QA standpoint, and specifically how it ties into the reduction of risk in terms of post-release debugging, the added latency again, and the potential data leaks that occur when these issues are not addressed. So first, we have to understand the significance of leveraging product agnostic best practices, as it says here, in order to simplify the dev test process. We just touched on specifically the benefits to utilizing interoperable solutions that enable enterprises to gain full visibility into processes, which ultimately help them optimize their in-app security. And another component to this is the utilization of real devices. Despite your QA team's geographic location and the scope of the project itself. So the goal here is to test on real devices in a controlled and private lab with access to all the devices and operating systems you'll need that actually reflect the conditions for the specific region that is critical, because especially from app protection policies that affect specific regions more so than others. And again, this ties into the ultimate goal of automating your testing coverage without diluting the app protection measures. And this is attributed in part to the organization's ability to gain full visibility into all paths of execution, including the vulnerabilities that lie within the application itself. All right, so what does the organization gain from executing performance tests earlier in the SDLC? This is the main point that we are discussing here. It's the ability to identify issues, bugs, and necessary security checks as they occur rather than post-release when it's exponentially costly for organizations to address. So note that test platforms should include UI performance monitoring, which capture performance transaction metrics of the mobile application executions. This includes detailed log files to help analyze and identify the bottlenecks themselves. And it can be used for one-time analysis, or you can incorporate it into your automated testing for regular monitoring to identify if the application changes or updates are resulting in the changes within the app performance. All right, so here we have a case study with a customer that truly showcases the value of leveraging the right solution and being able to use them interoperably as well. Okay, so let's go over the challenges here. So United Airlines aimed to test more than 20 B2B and B2C applications on devices running iOS and Android. So United had massive development operations within more than 250 applications and over 160 million users. They were conducting app-focused testing, including load and test automation, and it had also recently incorporated the continuous integration and continuous testing as well. And as you can imagine, with this level of demand that United receives, they recognize the need for a modernized approach and become more responsive and proactive from a testing standpoint. So the United QA team began using the digital AI SaaS offering that we previously covered here in order to run hundreds of tests daily across more than hundreds of iOS and Android devices, all hosted on within our data centers. As a result, within the first 9 months of implementation, United conducted over 2 million automated and manual tests, and this led them to saving over $24 million in test automation. Essentially, the test operations went from siloed, slow, and reactive QA processes to a fully automated continuous testing environment that operates around the clock. This improved the collaborations across these distributed teams by enabling remote access to their Chicago-based mobile device lab. And again, this ties into the digital AI approach, which entails leveraging full visibility and interoperability in order to create a truly intelligent platform that connects all software development and delivery efforts to business outcomes. This platform connects not only the app security and quality we discussed, but also agile planning and software delivery, so you can meet the increased market demand and optimize your app protection measures while scaling your testing continuously with all AI-based insights. With that, now we're going to have Mike Woodard. He's the product owner of Digital AI App Protection, discuss the ins and outs of app protection.
Thanks, Juan. A long time ago, having a strong perimeter around your data center and internal network was good enough. But more recently, and recognized as early as 2015, companies have created apps and provided APIs to bypass all that kind of good enough security. So now apps on devices in the wild are completely unregulated and definitely in untrusted hands. And attackers of all sorts, vandals, thieves, data hijackers, and spies are using your apps and your APIs to learn about and attack your backend systems. Confirmation that this is the case is easy to find, usually on, usually on the front page. Here are a couple examples of companies that have recently had breaches that they didn't want to have. And if you ask these, if all press is good press, they would probably, you'd probably be hard to press to find one of them that likes that. What's the cost involved here, and what can we do? So adding protection always makes apps bigger and slower. Beside the code that you want to run, you've got to be able to run the code that's doing the protection. And so there's more code to be run, and it takes some of your CPU cycles to run the protection code and not just yours. Working with many customers and looking at many customer stories show us that protection is often an afterthought, and it really leads to weaker protection and kind of barely good enough customer experience. Usually what happens is an app is being developed, protection is kind of thought about at the end, and as they get to the end of the regular app development, they start trying to apply protection. And usually they put on lots of protection everywhere that is kind of needless and too heavy. And then they start doing performance testing and they find out their performance has really taken a big hit. And because there's the time pressure to release, there ends up being kind of careless protection tuning. So they start turning down all the protection mechanisms in order to get better performance. And usually what they do is, as soon as their performance threshold crosses into the safe zone, they stop what they're doing. And so in the end, they have ended up putting on a lot of protection, turning some of it off just to get the performance they need, without really going back and saying, do I have kind of the right level of protection that I need for my application now that gives me this level of performance? So it usually stops there, but it doesn't have to kind of be that way. So instead of doing the situation or the scenario that we had before, where testing and protection is done late, this shows a simple sequence where protection is applied early and then testing can be done on that protection. Now, this simple picture shows it going to deploy and monitor right away. But if your protection also includes monitoring, then as part of your testing, you can say, okay, the performance wasn't good enough. Let's go back and do a reprotection. Or you can say, the protection is too heavy or too light, so let's go back and do that. And so you can go through that optimization loop that you really need to do early in the process. And then once you deploy and it's out in the wild, you still have all those same monitoring capabilities that you had back here that you inserted at testing or protection, that now you can see what's going on with your app. And you can use the feedback from your monitoring to help us figure out, do we need to tune the protection in terms of, do we need to turn it up to counter new threats? Is there a part that is being exercised too much in kind of typical user cases, and we could turn down a little bit and get a little bit more performance? So you'll be able to answer questions like that. And so the kind of continuous testing gives us test correctness and the app performance data, and the threat analytics gives us the monitoring to generate the protection coverage and the live attack data. And by implementing that kind of protection early and tuning it early, you can have greater confidence that your apps, even though they're being executed in the wild on untrusted devices by the general public, are more secure than they were. And so in contrast to that first picture, where we had the kind of the corporate firewall network picture, and then the holes poked through it here, leading to the untrusted zone, you really extend your perimeter of trust out to those secured apps and devices. And now we're going to go to the demo that Guy is going to perform for us.
Great. Thank you, Mike. Let me share my screen. Okay, so I hope you can see my screen. Now, what I'm going to touch is on two very important concepts that are a real concern when you protect your app. The first one is what you want to verify is that there is no significant performance degradation due to the protection itself. So you want to make sure, you want to create some kind of a baseline, and you want to identify any deviation from that baseline. And when I'm referring to deviation, it can be in the device CPU, it can be in the memory, it can be in the response time of moving from one activity to the other. It could be in battery consumption, it could be in many aspects. So let's touch on that. Just a side note, the continuous testing platform within digital AI enables you to gain access to a huge amount of devices, browser, emulator, and simulator. What I'm going to show here are real devices, and let's jump into it. So this is a real iOS device, and I can fully control that device just by, working with it in the browser. I don't need to install anything, and I can go and install application and do whatever I want. So I have an application here that is a protected application. I'm going to launch it, and I'm going to use that application a lot in the demo. So it's just a simple demo application. If I will click here on the login, I will get some error, and I can dismiss this error and go back to the same screen. And here I can provide the username and password and enter, and the application expands. Now, what I want to do is show you how the concept of transaction looks like. So just to explain, transactions start when you click on something on the user interface, and it ends once the device finishes rendering the screen. Usually in between there will be some communication going back and forth to the backend servers to pull data and render that data. So I'm going to record here a transaction, and I want to record a transaction of the login. It means that I will start recording when I'm clicking here on the login button. So before I'm going to add here the username and password, and I'm going to hit here start recording. I'm going to use not the default Wi-Fi network condition but the 3G network condition, because if I have performance issues, it will magnify those issues. So I'm going to start my recording, and when the recording is ready, I'm going to hit the login button. When the rendering is finished, I'm going to hit the stop, and we will see how the transaction looks like and what type of data is being collected. So here it is. I'm clicking on the login. It was very quick, so it took a few milliseconds. And now I'm just going to name it login and save it. Now let's see how the data of a single transaction looks like and what it contains. So here you can see all the information about the transaction, the application itself, the version, the device, the screen size, the network condition. Here you can see a video of what happened during that transaction. And here you can see a lot of information, the duration, the speed index, the CPU, maximum and average memory, battery, network consumption. So it's very nice by itself to be able to collect all that information. You can also get the HAR file, all the communication, internal communication between the application and the backend and so on. But what is more important is how I can generate a baseline based on, usually, by the way, I will not record this transaction in a manual way. I will add that to my automation test by adding a start transaction and end transaction lines into my Appium test or whatever type of framework I'm using. So I'm going to my reporting system, and I'm going to my transaction view. And here you can see a aggregation of hundreds of transactions. So let me filter my login transaction. So I want to check all my login transaction. Let's see, maybe I want to check that only on iOS devices. It makes sense. And I want to group it by my application version. Sorry, not my application name, but my application version. And here you can see this is the baseline I was talking about. It shows me that here I have a huge regression in this version that got fixed in a later version. And this is just in the login screen. So every part of your application can be measured and can be compared to older versions. And here I can do the same with my CPU, my memory, my battery consumption, and really identify problem very early in the protection process. So this is, with regard to one of the risk around protecting your app, and if you would like to get the confidence that it doesn't impact your performance, this is an excellent way to do that. Next, I'm going to use the same lab of devices here with a few Android devices and the same banking application that I've showed you before. And the challenge here is to scan my entire app and verify that it doesn't crash in any operation that I'm performing. So after my protection, one of my concerns is that the application will change in some way and will behave differently from the original application. And I want an easy way to just do this validation and just verify that there are no changes in my application. So for that, we have a very unique solution. It's called the bot, and I'm going to create a new project here. And within that project, I'm going to select the banking application that I've shown you earlier. This will run on Android. And what we are going to do is we are going to leverage the AI capabilities of the bot, and we're going to use it on few devices. So I'm going to start an exploration here. I'm going to use a few devices because I want it to be fast, and I'm just going to trigger this exploration. What it will do, it is going to select. Let's think about a team that do an exploration, and it need to map an area. So each one of those explorers are navigating in different route in the area and start to map the area. So what we're doing here is we are mapping the application. And let's just see first that that the devices are being used here. So I'm going to the execution tab, and I want to see that the exploration got triggered with 3 devices as was requested. Okay, so we can see the 3 devices, and you can see that the application is being installed on all of those devices, and you will see that the bots will start to operate on the application. We click on different elements, we'll touch different parts of the application. And in order to see how this map of the application looks like, I'm going to open the graph here. And here you can see, this is what we currently know on about the application. We know that in the application, if I will click on the login, I will go into this alert dialog. And if I will refresh it, you can see that now we also know that if we will click on close, we will be back in the same screen. Now, this is a small part of the application. Obviously, I wanted to explore into other area of the application. But for that, we need to resolve something that is called a gate. You can see that the exploration ended because the bots identify that they need some input from the user. They cannot continue without some input from the user. And we identify a gate. And what we're going to do is we're going to unlock this gate. So let me explain what is a gate. So anything that is require input from the user is a gate. And in this case, we have a username and password login screen. And the bot obviously doesn't know how to log in. It needs your help to do that. So I can either add some code to in Appium to log in, but we have a much nicer way, which is the form format. And here I'm just, if you remember, the username is company and the password is company. And this is a very simple format that says, go into the username field, enter company, go into the password field, enter company, and just click on the login button. And as we are doing that, the gate got unlocked, and now we can go and we can continue the exploration. Now it makes sense. So I'm going to just continue the exploration and again trigger those devices to continue working and identify other parts of the application. So this is great. We are starting to explore more and more part of the application. As we are doing that, let's generate a few tests. And this is the unique thing here. We are able to fully autonomously generate tests based on the model that we created. So what it says here is that we can generate two tests. I'm going to generate those tests. And as you can see, those are the two tests that got generated. The first will navigate to the login screen. We click on the login button and we'll verify that I'm getting the alert dialog. The second will navigate to the alert dialog. We click on the close and we verify that we are in the login screen. Now I'm going to open one of those tests for editing just to show you how it looks like. Navigate to this screen, click on the login button and verify that we're getting this screen. As simple as that. And here I can add my own verifications and so on. So very quickly, we're able to generate at this stage a small amount of tests, and we can execute them just to verify that they are working. You remember that we're still running and exploring the application. And if we will open the exploration tab, we will see all the different devices and all the navigation through the different parts of the application, and you will see all the devices are working. Let's see how the graph looks like now. So here you can see that we identify other parts of the application. We were able to use the form to log into the application. And now there are more parts of the application that are getting revealed. And if I will continue to refresh my model, soon enough, you will see more and more parts. And here you can see how we can leverage both AI and a big amount of mobile devices to map and identify more and more parts of the application. So as you can see, we are bit by bit building a model that describes the application, and based on that model, we can generate more tests. As the model expands, we can, so here it says I can generate 6 more tests. So let's generate those tests. And you can see that there were 2 more gates that got identified. And here you can see the test. We have the first one that is currently getting executed. And here you can see more text that got generated. And as we speak, more and more parts of the application is being mapped in the exploration. And based on that, we can generate very quickly the tests to test this model. Now, if an automation engineer will get this task to automate an application and test all the screen, it's something that could take weeks, sometimes months. And this is something that I was able to demonstrate in a matter of a few minutes. So this is a very unique parts of our solution, and it complements the security protection part of our solution, because it really enables you to do a full crash detection. Obviously, once I've generate those tests, what I want to do is execute all those tests on different versions, screen sizes of my application. So if it is an iOS application, maybe I want to execute all of those tests on iOS 11, iOS 12, iOS 13, iOS 14, in maybe different minor version. So you get the point. And this is nearly effortless to generate and execute those tests. So thank you very much.
Awesome. Thank you so much, Guy. And now we're going to open the floor to any questions. All right. See here, we have a handful of questions. First off, Guy, I believe this one is for you. Are the CT or continuous testing environments uses real devices? So in other words, they're asking, does our platform utilize real devices, and if so, how many, and so on?
Yeah, so the platform utilize thousands of real devices, and it also supports emulators, simulators, and browsers. So you can access any type of physical or virtual resource.
Perfect. Okay. We have another question here. I believe this one is more app protection geared. So Mike, how do you actually tune the protection?
Okay, so in a protection, you have several protection primitives, which we call guards. And each of those guards is of a specific type. So it may checksum an area, it may damage or repair some data values. It could check to see that a resource hasn't been changed. And when you specify the guard, you specify where in your application you want it to run. So every time I get to a certain function, run this guard. And then a lot of the guards specify what you want to check. So I want to check some of this function, or I want to check all my bit code, or I want to, whatever it is that you want to check, you specify that. And then you also specify what should happen if tampering is detected and what happens if tampering is not detected. And so by doing that and by looking at a debug log or looking at the data that shows up in AppAware, you could see, for example, that a checksum was running way too often. It was running multiple times a second, and you realize, hey, that only needs to run, every 5 seconds or every 10 seconds or whatever you want. And so by looking at those logs, you can see what's happening, and then you can go down and say, okay, don't either move this checksum to a different place or only run it 10% of the time or something like that. So you've got a lot of different controls over how intensive those checks are, where they are, what they're doing, and you can tune your protection performance that way.
Right. Oh, perfect. And you also you mentioned the monitoring there. So another question we have here that kind of piggybacks on what you just said there. What information is actually returned from the monitoring itself?
So when you set up your protection, you create what we call an analytics guard, and then you can tell your other guards whether or not to report analytics. So that checksum that I was talking about before, you could say that's one that you want to report. And so when that checksum runs, if it detects no tampering has occurred, that is sent as part of the next event that goes up to the monitoring platform. Or if tampering has occurred, then that is sent up. And then all of that data that we've got about this guard ran and it detected tampering or not goes into a database. Then we've got a front end for it, and you can look at it and you can see basically how many jailbreak or root detection guards fired, which may just say this is an unsafe or a safe environment. If you have checksum guards firing, then you can be pretty sure that somebody's actively attacking that. And so you can be alerted when a checksum guard fires, for example. But you can get kind of broad views of where different events are happening in the world. Or you can drill down to see, oh, what is the specific username if you set it up to associate a username with a run? What is the username of the person who's got checksum guards firing? And then as you see those, then you can decide how to react to those. But you certainly get lots of information that you can drill down to very specific things that you're interested in.
Right. And also like in relation to having the accessibility to that information and having the full visibility there. Another question here, I think it pertains more from the quality standpoint, but also in relation to the visibility. This codeless solution that we saw here during the demonstration and we talked about during the presentation, is this available to the public yet, Guy?
It's currently in beta. We have a few customers that are is part of our, so it's available for any of our beta program customer and partners. It will be GA in just a few weeks.
Okay, perfect. And in relation to that, what are the benefits of the UX performance baseline?
Yeah, so the main idea of creating a baseline is that you don't need to specify whether 2 second or 3 second is a good value for your login. You just create a baseline and you want to identify any changes or any regression in the performance. So you say the concept is saying, okay, I have the application, maybe I will improve it in the future, but what I want to verify, and this is very important, is that I will not get regression in any of the performance aspects of my application.
Right. Perfect. And I think we have time here for one more question. This question is for both of you guys here, so you could go ahead and take your turns if you like. But do you have any recommendations for balancing performance and security? I guess this kind of wraps around like the whole presentation we gave here. If there's like something you want to sum up for each segment.
Yeah, I mean, in general, I mean, that is kind of the essence of what we talked about. The first thing is to do the protection as part of your testing cycle, so that during the testing you're able to identify those hotspots that the guy talked about, the regressions, the outliers, so that if you need to change something in your protection, the early testing will be able to detect that. And then using the controls that I talked about a little bit earlier, you could go in and say, okay, this guard is running too much. It's a little too heavy. Let's turn that one down a little bit, or let's move its placement. The other thing would be if you have threat analytics turned on, you'll be able to see how many events you're getting. And if you're getting too many events that way, you could turn down the guards that are doing the reporting there, so that they don't, that those guards don't run as often. And by doing this, if you can identify kind of where the performance sensitive code is in your application, that's a good place to be lighter on the guards and to put them in, if you can move them a little bit into kind of the UI components, where the time it takes somebody to touch the screen is way longer than it takes to do a checksum of your whole application, for example.
Right. And how about you guys from a quality perspective? Do you have any recommendations for balancing performance and security?
So I think that it's really vertical dependent. If you will go to financial application, the balance will really shift into the security direction. And if we are talking about gaming, for example, then the shift is into the performance direction. But if you are doing testing in the early stage and you know how to tune your protection, then you don't need to balance between those two. So continuous testing and testing early in your security cycles is something that will enable you to achieve both very high security as well as very high performance.
Perfect. Thank you so much. Well, gentlemen, I believe this is all the time we have for questions. There are a few other questions here. Please feel free to submit them to us, and we will make sure somebody gets back to you with the answers. And thank you guys so much. Thank you, Mike, for being here with us today. And that's all, folks. See you soon.
Thank you.
Thank you.